Lesson 17, translating between words and algebraic expressions. Today, our new concepts, we're going to take a look at a number of the ways in which we can translate a mathematical expression or a mathematical operation into a way it's written out in word form. By the end of our lesson today, our goal is to be able to translate from the expression to word form or from the word form to the expression back and forth so that we can use this as a common language when solving algebraic expressions. Here in this table, it shows you the different types of operations that we commonly use: addition, subtraction, multiplication, division, and the words that are associated with those words that mean that type of operation as you're reading out the expression in word form or in expression form. Addition: sum, total, more than, added, increase, plus. Any sentence that says any of these words, you're talking about addition. Subtraction: less, minus, decreased by, difference, less than, decreased by. Any of those words found in a sentence mean that that's the type of operation that's happening. Multiplication, division. Multiplication is product, times, and multiplied. Division, quotient, divided by or divided into. Again, when we're using these words, those are the operations that are being used in the actual phrase or in the word sentence that actually means what's going on in the expression. So if you take a look at the phrase, how it would be said, and then what it would actually be written as, this gives us a really good foundation for the examples that we're going to see and how we're going to begin our practice. 4 added to a number. Anytime it says a number, it actually represents a variable. So 4 added to something is like x plus 4. 7 increased by a number. 7 increased by means plus, so you have 7 written down. Increased by plus a number is the variable. So 7 increased by a number, or a number added to 4. Subtraction: the difference of 5 and a number. The difference means that subtraction is the operation, so that's happening right here in the middle, of 5 and a number. So 5 and a number in that order. 5 and a number, 5 and a number would be x in this case, so the difference of 5 and a number is written just like this. 8 less than a number. Sometimes when you're writing these out, as you're reading it, it's not necessarily written in that same exact form. So you have a number less than 8, or 8 less than a number. It's kind of written backwards here, which makes this somewhat confusing, but we'll get used to how it's written out in word form and then how we write that as an expression in the accurate way. So 8 less than a number. Multiplication: the product of a number and 12. Product is the answer to a multiplication problem, so you're looking for what's the solution to 12 times something or 12 multiplied by something. A number and 12 means that those things are going to be right next to each other for that multiplication. So the product of a number, x, and 12. The next example, a number times 3. A number times 3 is them written right next to each other, a number, which would represent our variable, and 3x. How about division? The quotient of a number and 6. Quotient is another way of saying what's the answer to a division problem. The quotient of a number and 6. A number and 6. Now here's again, it's written in the right order, a number and 6, where up here it was 8 less than a number, it's written in the reverse order. In division again, 10 divided by a number, 10 divided by x. That's okay if you're going to use something that is the real simple left to right way in which you're reading or writing something. That just makes it easy, but you can tell that there's different ways in which you might hear that a different way and have to understand that that means the same thing in terms of how the expression is written. Let's get into it. In example 1, translating words into algebraic expressions. We're going to read word phrases and then write them as algebraic expressions. Letter A says y increased by 12. Y plus 12. B, the product of x and 4. I always like to look for, right in the word itself, what operation they're asking for. When it says product, I know multiplication. X and 4 means that they're going to be right next to each other, 4 times x. Letter C, 8 less than the quotient of m and 15. 8 less than means minus, and then quotient means division. So there's 2 operations in this one. Well, how do you write that out if there's 2? Knowing your order of operations, you're going to want to write that first. So the quotient of m and 15 is written first, so the division problem, minus 8, because that's less than 8. Letter D, James is 6 years younger than Lydia, who is x years old. Write the expression that shows James's age. If Lydia is older and James is 6 years younger, you can take the x value and subtract 6 from it, so you have x minus 6. In example 2, you're going in the opposite order, translating algebraic expressions into words. So here's where a lot of our answers can vary because you might use a different type of way in which to write addition. Notice there's 1, 2, 3, 4, 5, 6 different ways to write plus or added or addition. there's a number of ways to write addition, subtraction, multiplication, and division. So your answers might be different in this way, which is why I really like this part of our problem today, or our lesson today. M plus 7 could be written as 7 more than M, the sum of 7 and M plus 7, as you're just reading it from left to right. Letter B, 9 less than Y, or Y minus 9, the difference of Y and 9. There's multiple answers. Letter C, 5 times N, the product of 5 and N. What you want to make sure that you're writing out when you see it in expression form is that you have the operation identified. So you more than, sum, product, less than, difference. Those key words are showing you what's happening. That makes writing that expression out a lot easier. Letter D, x divided by 3, x divided by 3, or the quotient of x and 3. Letter E, 27 minus 1/2 times 18. Here you've got two operations again. In this case, the order is a little bit different because normally you'd say, well, order of operations says we should do this multiplication first and then subtract. But because 27 is a positive number, it's subtracting from the smaller number, we want to write it in this correct order from left to right. The difference of 27 and 1/2 of 18. 1/2 of is another word for multiplication. So you have the difference of 27, so 27 minus 1/2 and 18. 1/2 and 18 right here. When it says of, it's being multiplied. You would have that then being subtracted from 27. Or 27 minus 18 divided by 2. 27 minus 18 divided by 2, or 18 times 1/2. You could write it either way. In example 3, it's showing you a word form, and the application is in savings. Jane is saving money to buy a car. She has X dollars saved and is saving Y dollars per week. Write an algebraic expression to represent the total amount of money she will have saved after 52 weeks. So she has X dollars, and she's saving Y dollars per week. So Y is going to be multiplied by the number of weeks. You've got two different variables here, the dollars she has saved and Y, the dollars she's saving per week, and there are 52 weeks in a year. How much money would she have? You take initially what she has saved, and you add that to the 52 weeks and what she saves per week. Jane will have X plus 52Y dollars after 52 weeks because you're taking that dollar amount per week, multiplying by 52, and adding to what she already has. Let's take a look at our lesson practice problems, and you get started with your assignment for today. Lesson practice A. It says write each phrase in algebraic expression. So if it's in a word form, we write it in an expression. If it's in a expression form, we write it in a word. Letter A, the product of x and y. Product means multiplication, and I have x and y, so this would be 8x. Letter B, 18 minus y. I would write 18 minus a little minus symbol y. C, 7 more than 5 times x. Here you've got two operations. More than is addition, times is multiplication. 5 and x are going to be multiplied plus 7. 5x plus 7 is how you'd write this out. D, Raquel is 2 years older than Monica, who is x years old. Write the expression that shows Raquel's age. Well, Monica's x years old and Raquel's 2 years older, so you'd have x plus 2. Now in E, F, and G, it says use words to write each algebraic expression in two different ways. Here's where your answers might be different than mine because there's multiple ways to write out these expressions. You've got 10 divided by s. You've got the quotient of 10 and s. Be ways in which to write that out. Letter F, 5 minus r, or r less than 5. The difference of 5 and r. 3 ways to do it. Letter G, you got 3 times m plus 7, or the product of 3 and m more than 7. The sum of 3 times m and 7 is being added to the end. So you have multiple ways in which to write that out. When you have two operations, make sure you separate those operations in how you represent that. Continuing down to the next page, H, I, and J. Letter H has multiple operations here again, so let's identify the two operations as we write this out. Here you would say 3/4 times x plus 9, or you could say the sum of, sum would be addition, the product of 3/4 and x. Letter I. The quotient of means division. The quotient of 3 less than x. So you have x less than 3. Or you could say the difference of x and 3 divided by 2. The difference of x and 3, so x minus 3 divided by 2. 3 different ways to say it. John has D dollars in a savings account. He withdraws X dollars each week for 15 weeks. Write an algebraic expression to represent the amount of money that will be left in the savings account at the end of 15 weeks. So he's got D dollars, and he's got X dollars for each of the 15 weeks, and you're subtracting in this case. So you would say that it's D minus 15 times X. D minus 15X. Hope that helps. God's blessings on your assignment.